Hey, hey, teach me how to plug it. Hey, baby, like smoke. What?
Math Morning, Mr. Dirk is back at it again. Today we'll be solving quadratics by factoring, and I got a new shirt. Boom.
Just like the guy in the cat shirt said, we'll be solving quadratics by factoring. We're going to use the Australian method we learned in the last video, so I'm going to highlight some famous Australians during this video. The first one right here, this is Hugh Jackman. You might know him as Wolverine from the X-Men. So quadratic, just so you know, that's going to be a polynomial that has an n squared. That's what a quadratic is. So if I say quadratic, there's going to be an n squared or an x squared involved in this. So here are some tips. Make sure the squared term is positive. We have n squared. If this was negative n squared, we'd have to move it to a different side. Next tip, remember to use the zero product property. So when we do this, we're going to factor, and we're going to get two binomials, and it's going to equal 0. That means that this side or this side can equal 0. So this can be 0, or that can be 0, because at the end it's going to equal 0. The zero product property says anything times 0 equals 0. Just like A times B will equal 0 if A equals 0 or if B equals 0. So we're going to factor and then set up two binomials and make them equal to 0. So step one, we need to make this in standard form. So I want all of these things on the left side of the equation, and it should equal 0. So let's start. Let me do a plus 3 on both sides. That cancels, so I have n squared plus 3 equals, that cancels, 4n. Then I'll do minus 4n minus 4n. That cancels, so this side is 0. And then if I want it to be in standard form, the highest exponent goes first. So n squared, and then the next highest exponent would be the 1 on top of that n, so minus 4n, and then a plus 3. So it's a quadratic we have in standard form. Now I need to do the Australian method. So I'm going to have two parentheses. I look at the first term, right? In front of this n squared is a 1, so like 1n. That means there's going to be 1n here, 1n there, so I can just write n times n. This I divide by 1 because there's a 1 in front of this n. But if you divide by 1, it's really the same thing, so I don't even have to divide by 1. I can get rid of that. And this is going to equal 0 because it equals 0 up here, so I have to have it equal 0 down here. So back to the Australian method. We multiply the a in front of the n times the c. 1 times 3 is 3. And then we're going to add numbers that will equal this negative 4, the b term, negative 4. So what numbers multiply that equal 3, and when I add equal negative 4? Well, I know 1 times 3 is 3, and 3 plus 1 is 4, but if I want it to be negative 4, I need to use negative 3 times negative 1. So I take these numbers, put them in here, negative 3, negative 1. I can check to make sure that this will equal this quadratic. N times n is n squared, negative 3 times negative 1 is 3, negative 3n minus 1n equals minus 4n. Alright, so I did a quick check, and now I want to use the zero product property, so I set each of these equal to 0. N minus 3 equals 0, or n minus 1 equals 0. I solve, plus 3 n equals 3, or plus 1 n equals 1. So I just solved the quadratic. I want to plug these back in, make sure that they give the right answer on the original equation. So if I put in 3, 3 squared, that's 9. Minus 3 plus 3 times 4 is 12. Negative 3 plus 12, that's 9. So that checks out. If I want to put the 1 in, 1 squared is 1. Negative 3 minus 4 times 1 is 1. Negative 3 plus 4 is 1. So that also checks out. So that's it. That's how you solve this equation by factoring. So here's a new example and a new famous Australian. This guy, I think his name is Chris Hemsworth. He's from Thor. I never saw the movie, but I heard it was good. Alright, let's do the Australian method. First, I want it to be in standard form, so I do minus 5 on both sides. This equals 0, and now I have 7a squared plus 2a minus 5. Alright, I'm going to write down the parentheses, just like that. What should I put at the beginning of each one? Well, this is 7a squared, so I need to write 7a. 7a. And then this is being divided by 7, and it will equal 0. Alright, so that's set up with the Australian method. And now I take the a term times the c term, right? The a times the c, that is 7 times negative 5, and that equals negative 35. Okay? Now I look at this 2a, right? The b equals 2. So what numbers multiply that equal negative 35, and when I add them equal 2? Alright, well, 7 times 5, that's 35. If I make one of them negative, either the 7 or the 5, then it'll equal negative 35. If I want them to equal 2, I think the 7 should be positive, right? So if I do 7 times negative 5, that equals negative 35. And if I do 7 plus negative 5, that equals 2. Alright, so that works for what I want. So if I put plus 7 here and minus 5 there, does that work? Okay. So now I need to look at this and factor something out. This has 7a and that has 7, so I can factor out a 7. So I'm going to rewrite it as 7 times a plus 1 times 7a minus 5 divided by 7, and that all equals 0. Now that 7 and that 7 cancels, so I have a plus 1 times 7a minus 5 equals 0. The zero product property says I need to set each of these equal to 0. So I do a plus 1 equals 0, or 7a minus 5 equals 0. So when I solve, I do minus 1, a equals minus 1, or plus 5 cancels, 7a equals 5. Need a little more real estate down here. Then I divide by 7, a equals 5 divided by 7. So I have a equals minus 1, or a equals 5 over 7. Some people, they get this fraction and they want to give their answer in a decimal. A lot of students do that. You guys don't like fractions. But if you take this fraction and turn it into a decimal, and then the decimal is incorrect, your answer will be wrong. If you just leave it as a fraction, that's one less step you have to do, and you don't have to worry about getting it mixed up. So if you leave it like that, you are good to go. Alright, moving on. Alright, here's the next example and the next famous Australian. Steve Irwin, crocodile hunter. This guy was a legend. Steve Irwin, look him up. So this one says find the zeros of the function. This is called function notation. What this really means, when you have something like h of x, that's what we say, that's the same thing as y, right? So you could write this as y equals 3x squared minus 2x plus 5. And when you find the zeros of a function, that's when y equals 0. Okay, so basically this h of x, that just means y, and to find the zeros means when y equals 0. So we can write this as 0 equals 3x squared minus 2x minus 5. In this function notation, that's going to be really important in Algebra 2. So just be aware of that. All right, let's do it. Australian method. So we're going to have 0 equals, we're going to set this up, two parentheses, two pairs of parentheses. We're going to have a 3x at the beginning of each one. And then we divide by 3. Now we need to find out what numbers multiply 3 times 5. That equals negative 15. And what numbers add up to negative 2? That's the b term. Alright, what is that going to be? So 3 and 5, I wrote negative b, negative 2. I know 3 times 5 equals negative 15. If I want to add these so they equal negative 2, I think I need to make the negative 5 negative so that negative 3 plus negative 5 equals negative 2. Okay? So we're going to use these two numbers. Now I just have to put them in up here. So I can do 3x plus 3, 3x minus 5. So now, can I factor anything out? Well, these both have a 3, so I can say 3 times x plus 1, and these I can't factor anything out, so that's 3x minus 5 divided by 3. Now those 3's cancel, so I'm left with 0 equals x plus 1 times 3x minus 5. Zero product property tells me I set each of these equal to 0. So x plus 1 equals 0, or 3x minus 5 equals 0. Alright, now I solve minus 1, x equals minus 1, or plus 5 cancels, 3x equals 5. Divide by 3, x equals 5/3. So I have x equals negative 1 or x equals 5/3. And you might still be thinking, why is this called the zeros of a function? All right, and why are there two of these? So if I was going to graph this function, and you'll learn more about this, I think 2 chapters from now. The zeros of a function are when y equals 0. Well, this is the y-axis, right? So where does y equal 0? Right here. So y equals 0 is the x-axis. Where does this cross the x-axis? Well, it says x is negative 1 and 5/3, which is a little bit more than 1, almost 2. So that's like right there. So when you graph something that has an x squared in it, it is shaped like a U or an upside down U. So this function or equation really looks like this when you graph it. The zeros are right there and right there. And you learn more about that in 2 chapters from now. And when you graph a linear equation, this only crosses it one time. All right? So keep that in mind as you go forward.
First things first, I'm the realist.
Another famous Australian. We've got Iggy Azalea. Iggy. All right. So one more example to do. So find the zeros of this polynomial function. Again, how do we do that? That's the same as just saying that f of x is y and that this is 0. So 0 equals x squared minus 5x minus 24. We say a 0 equals, let's do some parentheses. Bam, just like that. There's a 1 in front of the x, so I just write x right here, x right there. I can divide this by 1, but if there's a 1 in the front, you don't even have to do that. All right, so what numbers, when I multiply, that equal negative 24, because I did 1 times negative 24. So multiply, that equal negative 24. And when I add, they equal a negative 5. You can always list them down if you can't figure it out, but I know 8 times 3 is 24. If I want it to be negative 24, one of these has to be negative. If I add them and I want it to be negative 5, I know that the 8 has to be negative because it's the bigger number. So when I add them, if 8's negative, it will be negative 5. So I go ahead, put these in there, negative 8 plus 3. I don't have to factor anymore. It's all set like this. And now I set each of these equal to 0. And you could always, let me just check actually. Let me check to make sure I did it right. X times x, x squared, negative 8 times plus 3, negative 24, negative 8x minus 3x, negative 5. All right, so I checked. That's good. So I do x, I don't need that parenthesis, x minus 8 equals 0, or x plus 3 equals 0. I solve them, plus 8, x equals 8, or minus 3, x equals minus 3. Check that out. And I can test if I put it in the function, x squared is 64. 5 times 8 is 40. So 64 minus 40, I think that's 24. 24 minus 24 is 0. If I put in negative 3, negative 3 squared is 9. Negative 5 times negative 3 is plus 15. So 9 plus 15 is 24. 24 minus 24 is 0. So I checked. We're good. So now is your turn. I want you to pause the video, try these problems, or you have to wrestle an alligator. Just kidding. Just try them. All right, here we go. So let me begin. I want to get everything on the same side as the c squared. It's positive, so I want to keep it positive. So I can do minus 11c and the plus 5, minus 11c and the plus 5. Cancel, cancel. I'm left with 0 equals 2c squared minus 11c plus 5. All right, let me move it over a little bit. When I do the Australian method, and just like Steve Irwin, the crocodile hunter, he's Australian, I need to put a 2 at the beginning of each of these parentheses, and then I put a 2 down here. Then I multiply 2 times 5, that equals 10. So when I multiply, it equals 10. And then add, we have negative 11 for the b term. So what two numbers, if I multiply, equal 10, and if I add them, equal negative 11? Well, 1 times 10 is 10, right? 1 times 10, that equals 10. And if I add them, they equal 11. If I make them both negative, it still equals 10, but when I add them, it will be negative 11. So what I can do is write, this is going to be 2c, my bad, 2c. I can do minus 1 and then a plus 10. So now, not plus 10, minus 1, minus 10. They're both negative. Now I try to factor. So 0 equals, can I take anything out of this? Nope. So I leave it like that. 2c minus 1. Can I take anything out of this? Well, I can take out a 2. So let me factor out a 2. And I'm left with c minus 5. All right, because 2 times c is 2c. 2 times negative 5 is negative 10. So now those two cancel. And I'm left with 0 equals 2c minus 1 times c minus 5. The zero product property tells me to make each of these equal to 0, or the c minus 5 equals 0, and then I solve them. Plus 5 plus 5, that cancels. C equals 5. Over here I do plus 1 plus 1. 2c equals 1. Divide by 2, divide by 2. C equals 1/2, or C equals 5. There we go. Example 1. Done. All right, up here. Find the zeros. Like we said, that's the same as just saying 0 equals x squared plus 13x minus 48. All right, Australian method. I make my two parentheses. There's a 1 in front of the x. So all I have to do is write x there and an x there. And I don't have to do divide by 1 because it's going to be the same thing. And then I think, okay, what numbers multiply that equal negative 48, and when I add them equal 13? And you could always write down all the factors. I know that 16 times 3 equals 48. If I want it to equal negative 48, one of these have to be negative. So when I add them, which one has to be negative to equal 13? Well, it's a positive number, so the bigger number should be positive. So 16 times a negative 3 will equal a negative 48, and if I add them, it equals 13. So these two numbers I put in the factors. So plus 16 minus 3. Now I make each of these equal to 0. X plus 16 equals 0, or x minus 3 equals 0. Minus 16 minus 16. X equals minus 16, or plus 3 plus 3. X equals 3. So there we go. There are my two answers, and you could always put those back in and solve them. But that's it. All right, this is a tough one, so you might have to watch this video again. But good luck with the mastery check. Good luck with the packet. You got this. And I'm going to end with a video that another high school made about factoring. It's the same song I played at the beginning of the video, if you remember. So that's it. Good luck. Dirkus out.
Hey, hey, teach me how to factor. Hey, it'd be like Schultz. What? Can you teach me how to factor? You know why? Cause all the students after. Hey, all I need is a real good quadratic, and for you to back me up and check it. Get it? Get your terms lined up, make them high to low. Look for a GCF, that's something everyone should know. We got two terms and a minus in the middle. Now we cooking, like flipping bacon on a griddle. Okay. Both the digits gotta be perfect squares. 1, 4, 9, 16, 25. Overhead, DOS. All the students trying to get it. You gotta recognize when I spit it. All day. Set up two sets. Put an X in each. Minus here, plus there. Listen when I teach. I make the class shine bright when we start to do it. This one's a piece of cake, so I had to do it.
Teach me how to factor. Teach me how to factor. Teach me how to factor. Teach me how to factor.
Everybody factor. Everybody factor. Everybody factor. Check my work when I factor.
Teach me how to factor. Teach me how to factor. Teach me how to factor. Teach me how to factor.
Everybody factor. Everybody factor. Everybody factor. Check my work when I factor. I'm Mr. Winner. Yeah. Growing up on a tractor. You know I'm from Greenville, but I teach you how to factor. Yes, sir. Step up in my class and all the students hear me. If you got 3 terms and a plus in the back, I hear the class screaming like, hey, this is whack. These signs must be the same when you follow the flow. They like, how you do that when I factor on the floor? Set up 2 sets, put an X in both. The signs in the middle will be showing up the most 3 terms. and a plus in the back. Your signs will double up like a Wendy's double stack. I take this to the class when I show them how to factor.
Teach me how to factor. Teach me how to factor. Teach me how to factor. Teach me how to factor.
Everybody factor. Everybody factor. Everybody factor. Check my work when I factor.
Teach me how to factor. Teach me how to factor. Teach me how to factor. Teach me how to factor.
Everybody factor. Everybody factor. Everybody factor. Check my work when I factor.
Back to the class, you know I really like the factor. The roots of the quadratic, yeah, that's what I'm after. GCF first, then for to check your work. We got one more case, so we have to take a look. We bout to factor, get an answer with two signs. This one's the hardest, so listen to my rhymes. If you got three terms and a minus at the end, the signs will be different where they go, that depends. The larger of your numbers gets the sign from the middle. This problem's not too bad if you study just a little. Now pick up your pencil, I don't wanna hear you fussing. Teacher swear I got them students with the brains all a bustin'. Nah, you really gotta get this lesson. This problem's hot, we just took it out the math oven. I like to factor and get everybody working. I yell, yeah we do it, and everybody factors.
Teach me how to factor. Teach me how to factor. Teach me how to factor. Teach me how to factor.
Everybody factor. Everybody factor. Everybody factor. Check my work when I factor.
Teach me how to factor. Teach me how to factor. Teach me how to factor. Teach me how to factor.
Everybody factor. Everybody factor. Everybody factor. Check my work when I factor.